All right, secant and cosecant. Now, let's look at the sine curve. Y equals sine of x. Okay, I'm going to make a little graph, sine chart. So, if we're at 0, what's the sine of 0? Thank you, it's 0. What's the sine of pi over 4? 0.7071. Pi over 2, 1. 3 pi over 4, 7071. Pi, 0. 5, 5 pi over 4. And then 3 pi over 2, negative 1, 7 pi over 4, negative 0.7071, and then 2 pi, we're back to 0. Now, what is the cosecant function? It is the reciprocal of sine, right? So we have to take the reciprocal of the y values. So what's the reciprocal of 0? What's 1 over 0 equal? Not 0. Undefined. What's 1 divided by 0.7071 approximately? Somebody calculator that. 1 divided by 0.7071. Glad all of you have your calculators in your hand doing this to help me out, you know. Might be a little bigger than 1.2. 1.414. So let's just say 1.4. Okay. Pi over 2. What's the reciprocal of 1? 1. And then 3 pi over 4 is 1.4. Pi is back to undefined. And then we go the negatives now. So then we're at 5 pi over 4, negative 1.4, 3 pi over 2, negative 1, 7 pi over 4, negative 1.4, 2 pi, undefined. So I'm going to go 4 to get to pi over 2 this time, just so I can fit things on before I get to all my numbers. All right, so if I graph my sine curve first, because that's what I want to do with this, graph my sine curve first. Then, where I'm undefined, I'm going to put an asymptote there. For those of you who took Algebra 2 last year, this is an asymptote. Okay, for those of you who haven't taken Algebra 2 yet, an asymptote, a vertical asymptote is a line that a graph cannot cross. Okay, a line that a graph cannot cross. It might come up awful close to it, but it can't cross it. So what my graph is going to end up doing is at pi over 2, we're in the same place. We're at 1 for both of them. Pi over 2, 1, pi over 2, 1. At pi over 4, I'm at 1.4. So I'm about there. 3 pi over 4 and 1.4. So what happens, it kind of looks like a parabola. And that is y equals cosecant of x curve. Okay? Y equals cosecant of x. Looks like that. Looks at y equals secant of x. The secant is a reciprocal of what function? The secant is the reciprocal of cosine of x. So instead of doing all the big old charts like I did last time, it's the same process, so I think hopefully you'll get it. All right, so if I graph my cosine curve, where's cosine start? 1, then I go to 0, then I go to -1, then I go to 0, then I go to 1. Where do you think I'm going to put my asymptotes on this one? Where do you think the asymptotes will go? Well, on the secant curve, it's where I divided by where I had 0 originally, right? So it happened at pi that I was undefined. Well, where is 0 on the cosine curve? Pi over 2. So where I have that, that's where I'm going to have my asymptotes. So if I graph secant, kind of going to be a parabola that goes down like this. You're getting close to your asymptote lines without crossing them. But now I only have half of a curve. So what I should do with cosine is I should extend it to the 5 pi over 2. Because it keeps going at 5 pi over 2, we're going to be at 0. And then I'll put another asymptote there. And then I'm going to graph my secant curve there. And that's what it should look like. Now, if I wanted to, I could go back this way also. And put an asymptote over here if I wanted to. And then go up like this. Okay. So, either way, you only need one up parabola and one down parabola, but I want the whole parabola, not a half and a half. Okay? So either go all the way to negative pi over 2 or go all the way to 5 pi over 2 when we're doing secant of x. Okay. Now, let's start having some fun with some of this. I got to look at one thing really quick at my plan book here. Figure out exactly which ones we're doing. 31 through 35, 43 and 45, 31 through 35, 43, 45. Yeah, that's what we're doing. Okay, just making sure. Okay, so let's graph here now. Y equals 3 cosecant of x. Okay. Now, what's my original function? And you'll say, well, cosecant is. Well, actually, the original function of a cosecant is sine. So I'm first going to graph y equals sine of x. Then, before I graph the cosecant, I'm going to graph y equals 3 sine of x. So what does that 3 out front do to the graph? Y values is times 3, so it gets stretched up vertically. Okay? So instead of going 2 spaces when I make my graph, so when I make my graph here, instead of going 2 spaces to get to 1, I'm just going to go 1. Because things are going to get stretched out, and I'm going to run out of room if I don't do it this way. So you want to look at your equation to know how you're going to graph it. Okay, and then there's no 3s or 2s or 6s or 5s or anything like that back there. So I can just graph normal. So I can go pi over 2, I can go 4 spaces, I can go 6 spaces, whatever you want to do. So cosecant comes from the sine curve. So we start with the sine curve, 0, 1, 0, -1, 0. And then we're going to do 3 sine of x. Okay, we're not going to go straight to 3 cosecant of x. We're going to go 3 sine of x first. So that way we know where our bottom, our minimum and maximum points are. Then I'm going to throw down some asymptotes. So one goes right here. One goes right here. And then, finally, I'm going to draw my parabola. Okay? So see how this dropped by about 1 square when I got to here? So I'm going to go 1 square up when I get to there. Everything is hopefully fairly uniform. Okay? Let's go in 3 times of something. Y equals cosecant of x minus pi over 4. What's the base function of cosecant? Sine. So we're going to go y equals sine of x. Then we're going to do what it tells us to do with the sine of x first. So then we're going to go y equals sine of x minus pi over 4. So pi over 4, so I'm going to go 4 to get to pi over 2, just so I have enough room for everything. Okay, So y equals the sine of x, 0, 1, 0, negative 1, 0. And then what does minus pi over 4 do to my graph? Goes to the right, pi over 4. How many squares on my present graph up here is pi over 4? 2. Because if I go 8 squares to get to pi over 4 would be 1/4 of the 8, which is 2. So everything goes 2 squares to the right. So where are my asymptotes going to be located for this one? Well, my asymptotes for this are going to be where my original sine function hits the x-axis. And then I just graph my parabolas. Do my parabolas have to be in the perfect? No, they don't. Just as long as they go close to your asymptotes. I don't want parabolas to go like this. I don't want you to do that. That's sloppy. I don't like sloppy. You got to go close to your asymptotes. So you got to be like that. Okay, let's do one more. Let's do one involving period and a shift. So let's do y equals secant of 2x minus pi. Y equals secant of 2x minus pi. I got an issue with this one. What's my issue with this? You don't want the number right next to the x. The number has to be on the outside of parentheses. So really, I'm going to graph y equals secant of 2 times x minus, if I factor out a 2, I'm dividing by 2. So it'd be pi over 2. All right. So what's my base function of this one? Cosine. So I'm going to graph y equals cosine of x. Then I'm going to graph y equals cosine of 2x. Then I'm going to graph y equals cosine of 2 times x minus pi over 2. Then I'm finally going to get to my secant graph. So I'm going to graph a bunch of cosines first. What's that 2, the orange one, what's the 2 going to do in my graph before I totally build my graph? What's the 2 going to do in my graph? Is it going to stretch it twice as wide? No, it's going to shrink it half the size. So I want to go at least 4 to get to pi over 2. So, and then nothing's happening vertically at all. I don't have an addition on the outside or a number in front. So this won't be bad. So I'm going to first graph y equals cosine of x. 1, 0, negative 1, 0, 1. Then I'm going to go to orange. Cosine of 2x makes everything twice as skinny. So I'm going to start in there. So instead of going over 4 to get to my x-axis, I go to 2. Then negative 1, 2. And then I'm going to move it pi over 2 to the right. Pi over 2 to the right is, in this graph, I went 4 to get to pi over 2. So I go 4 squares to the right. Now, where are my asymptotes? Where we hit the x-axis with my blue graph. So it's going to be there and there. And so if they're 4 apart, I'm just going to go back here once. And then I'm going to finish out the blue curve back to there. Because that's what it's going to do, right? So if that's what it's going to do, then I can draw my asymptotes and or my parabolas, and they're going to be skinnier parabolas because my asymptotes are skinnier. But now it's going to look like that. Okay? That's the basics of what we're doing today. And there was only one assignment. There's only 5 problems. Okay? So we will get after that. Your problems are right there.